The overall objective of this unit is to increase awareness about the research activities taken up by the IITs and the scientific community for design and development of assistive technologies for visually impaired people. The independence and quality of life of people with disabilities and others with functional limitations are greatly increased with the use of assistive technology. Availability of assistive technology is currently limited to those devices which can be purchased and those fabricated on a custom basis. The limited size of the market often creates a significant barrier to the commercialization and availability of assistive technology devices. New devices, technologies and techniques of using existing technologies are continually being developed through assistive technology service delivery providers and research and development projects, and most importantly by people with disabilities and their families, most of which will never become available commercially and thus not available to many people who could have benefited from them. However, the information about the devices, particularly the engineering information necessary to fabricate them, is available. Every civilized society has to strive towards providing means for independent living with dignity to every member of the society. Apart from economic and social backwardness, differentially abled in India and rest of the developing world face many more severe challenges related to mobility and education. This has a direct bearing on their economic independence as well as social integration. AssistTech is an interdisciplinary group of faculty, research staff and students at IIT Delhi which is engaged in modern technology for finding affordable solutions for the visually impaired community. The focus is on mobility and education, which are considered as fundamental to enable any person to live independently and with dignity. Apart from working on specific solutions based on needs identified by the users themselves, the aim is to create an ecosystem that helps sensitize and ignite a number of young minds towards real day-to-day challenges of the differentially abled community. Access to diagrams has been one key challenge in providing education to visually impaired people, especially in subjects like science, mathematics, geography, economics. Set up as a part of the AssistTech group, the Center of Excellence in Tactile Graphics at IIT Delhi aims at empowering the persons with visual impairment by providing access to figures and diagrams in a meaningful and comprehensive manner so that their understanding and perception development is not affected. The center has developed technology for producing high quality yet very affordable tactile diagrams using 3D printing for mold making and thermoforming for actual production of tactile diagrams. Affordability is one of the major design considerations which is kept in mind while designing products at AssistTech, since 90% of the visually impaired community live in low income settings as per the World Health Organization. AssistTech is also working on using the latest image processing and machine learning techniques for automating production of tactile diagrams, meeting applicable international guidelines. AssistTech works on translational research based approach. AssistTech's user-centric approach aims to develop products for visually impaired which are affordable and easy to use. While 7 of them are sponsored, the others are in their early stages and at present are lab prototypes and are being used for user feedback. The flagship product from AssistTech Lab is a mobility aid for visually impaired people called SmartCane. SmartCane device is an electronic travel aid which fits on the top fold of the white cane. It serves as an enhancement to the white cane and overcomes its limitations by detecting knee above and hanging obstacles. For safe mobility, it is important that such obstacles are detected early. The cane has other uses as a spatial awareness device, as it can detect presence or absence of objects in the surroundings. Further, as compared to the white cane, the detection distance is increased from 0.5 meters to 3 meters. It informs the presence of objects before actually touching the object with the cane and thus helps in preventing unwanted contact. This avoids socially awkward situations like collision with people while walking or unsafe collision with animals or into trash. SmartCane device uses ultrasonic ranging to detect objects in its path and generates tactile output in the form of different vibratory patterns. These vibrations convey the distance information and thus enable the user to negotiate the obstacles from a safe distance. With simple orientation and training, any visually impaired person who is a regular user of the white cane for mobility can benefit from this device. Now let us discuss some of the key device features of Smart Cane. It has adjustable detection range ranging from 3 meters to 1.8 meters, so that it can be used both outdoors as well as indoors. The sensors can detect a 3 centimeter wide pipe from 3 meter distance. It has intuitive and distinctive vibration patterns indicating obstacle distance. Ergonomic grip for comfortable holding and cane tapping is provided. Adjustable sensor mechanism for use by persons of different heights. Inbuilt rechargeable battery with 10 hours of battery backup and easy charging is provided. It can be easily attached or detached from a compatible white cane. It conforms to international quality standards CE ISO 9001-2008. Smart Cane ensures independent mobility, safety and gives confidence as it detects hazardous raised knee above obstacles, gives pre-warning of obstacles and allows path finding without collision. It reduces injuries and awkwardness of collision during mobility. Smart Cane is easy to use as it enhances white cane use, has a convenient ergonomic grip. It is tested for robust and reliable use. The other project on which Assistech is working on is called Onboard. It's a bus identification system. Public transport is the only viable mobility option to seek education, work and social connectivity for a majority of blind and visually impaired persons. They face major difficulties in independently accessing public buses since they cannot read the route number and are unsure about the physical location of the bus and its entry or exit doors. Despite constantly seeking help from sighted fellow travelers, blind persons frequently miss their desired bus, are unable to reach the entry gate and frequently get hurt in the process. The possibility of these events adds to the fear and anxiety of the visually impaired traveler. Onboard is a radio frequency based solution which consists of two modules, a mobile-like handheld user module and a bus module installed inside the bus. Once at the bus stop, the user presses the query button on the handheld module to obtain route numbers of the buses in the vicinity. These numbers are read out to the user via a speaker or a headphone in the user module. This essentially serves the first problem of helping the user know if the desired bus is there at the bus stop or not. Once the route number of a desired bus is read out, the user needs to select it by pressing the selection button. This triggers a voice output of the number from a speaker installed at the entry door of the bus, thereby assisting the user in orienting and navigating towards its entry. The select button can be pressed multiple times to trigger the guiding voice output from the bus. Once the select button is pressed, it activates a bulb at the driver panel, thereby informing the driver about a person with special needs who wants to board his particular bus. Another project on which Assistive Technology Lab is working on is an indigenous refreshable braille display. It is a device that enables people with visual impairment to read digital text through tactile interface. Textual content in portable document format or PDF, Word documents, etc. can be read using the display without having to emboss or print on braille paper. Affordable displays gives them access to diverse textual media and opens doors for development of various products that shall strongly empower them in the fields of education, employment and quality of life. Braille tutor systems, deaf-blind communication devices and tactile math displays are some of the examples of products thus derived that entail mainstream integration in these fields, free from the demerits of both auditory devices and paper embossed braille, and at a price point below 1/7 of that of commercially available displays. The indigenous refreshable braille display has been developed deeper penetration in both developed and developing countries. Refreshable Braille display consists of an array of refreshable Braille cells which provide a line-by-line output of the digital content using a tactile interface. Device has a note-taking capability using an inbuilt Perkins-style keyboard which includes reading, writing and file management on device. Device supports Bluetooth, USB, Wi-Fi interface and can be connected with computers and smartphone. It is a standalone and portable device with a user-centric and ergonomic design. For scalability of the product, a collaborative ecosystem is required. The project team has been built to take care of the different expertise and experience required for such a complex technology and device development project. In IIT Delhi itself, the project represents a strong collaboration of mechanical engineering and embedded devices group. Further, the industrial partners Phoenix Medical Systems brings to the table the mechanical fabrication, production and quality experience, whereas Critical Solutions possess significant research and development experience with embedded hardware and software. The project team not only develops the technology but also works in close collaboration with non-government organizations to ensure feedback from the users and professionals. User interaction with consistent help from Saksham Trust has been an integral part of the development process. Direct user interaction at every stage, including problem identification, design, feedback and prototype validation, not only motivates and drives the process but also keeps it oriented towards the right direction. Assistech Lab is also working on a software tool called EduTactile. EduTactile is a cross-platform Java-based software which facilitates the creation of tactile graphics specialized for scientific and mathematical content. It automatically handles layout and formatting, thus relieving special educators and enabling them to concentrate on the content of the diagrams. During the development, feedback was taken from special educators as well as visually impaired students. Initial feedback has been positive regarding both the software as well as the quality of diagrams produced using it. Assistech is also working on a cell phone based indoor wayfinding system for the visually challenged called Roshni. Roshni is a portable and self-contained system fabricated using the commercially available infrared sensor suite. The system consists of a user module and a network of wall-mounted units spaced at distance intervals. User module is a waist-worn device comprising of receiver for detecting user movement and a user interface in the form of a mobile phone application. Each wall-mounted unit emits a unique identification tag that is associated with the location on the digital map of the building. The detailed map of the interior of the building can either be downloaded from the net or can be downloaded on the mobile phone at the point of entry to the building. By pressing keys on his or her mobile unit, the user can obtain directions to any desired location on the map from his or her current position. As the user moves in the building, the waist-worn module updates the position of the user. The navigation information is conveyed to the user acoustically using the text-to-speech engine of the phone application. Roshni has been developed to be applicable and available to users in developing countries. The underlying technology has a pending patent and the device is in final stages of development, user demonstration and feedback. Assistech is also working on the non-visual desktop access NVDA screen reader. Screen readers is an application software for computer accessibility for people with visual impairment. It interprets what is being displayed on screen and outputs textual, graphical and spatial information in the form of text-to-speech or a Braille output device. It is vital for the visually impaired users because in many cases like news, digital media is the only means of consuming and creating information. The most popular commercial screen readers for Windows like JAWS are very expensive, costing around $900 for a personal user license and more for updates and support. NVDA, which is supported by the NVAccess community, is a free and open source alternative. NVDA was created by 2 Australian programmers and has been made available since in over 40 languages. However, compatibility with Indian languages remain minimal and a vast majority of the employed visually impaired population in India work exclusively in Indian languages. The India Development Team addresses this issue. The project aims to develop the following: compatibility with Indian language text to speech engine, complete compatibility with all popular versions of key application software like Microsoft Office suite of applications, support for Indian languages keyboard layouts, development of NVIDIA application modules for some popular software for banking and ERP like Finacle and Tally,